Houseriver, and I am a senior solutions engineer here at Unravel Data. For those that don't know, Unravel Data is a data ops and FinOps industry-leading observability platform, and we're built for modern data stacks like Snowflake and others as well, like Databricks, BigQuery, EMR, Hadoop. Throughout my years as a pre-sales engineer in the data space, I've worked with some of the largest data customers, solving for some of their most complex challenges around using platforms like Snowflake. So in today's conversation, and as part of our series about controlling cloud costs, our topic is cost-aware data engineering, designing Snowflake ETL pipelines for maximum efficiency. So what we're going to do today is first talk about how organizations are currently trying to get a grip on and rein in cost, and why paying attention to how we design and develop our pipelines in Snowflake contributes to that effort. So I'll walk you through what some of the native out-of-the-box tools and features from Snowflake are in order to help run more efficient ETL pipelines. But also, I'm going to highlight some of those gaps, right, that they have. So things that I've seen that when customers are using this very powerful platform are missing, right? Missing features when trying to solve for things that are really pretty critical, right? So cost, performance, stability, those three main categories. Then I'm going to actually show you a demo, a short demo of a day in the life of how Unravel with our purpose-built AI helps to address these challenges, helps to fill in some of those gaps with those tools, and helps to equip data engineering teams, rather, to get the very best of breed when it comes to helping you design more efficient ETL pipelines in Snowflake. Okay, so let's begin. So today, if you're using some of the native Snowflake features, such as Snowflake tasks and Snowflake streams, which is kind of depicted with the screenshot I chose here that I'm showing you, in order to create your ETL pipelines, that's great, right? That's fantastic. We here at Unravel encourage and recommend our customers and our prospects, right, like you, to either start using them or to continue doing so, as this is best practice, and these are some pretty cool and powerful tools. So for those who are unaware, and just very briefly, streams in Snowflake allow for querying and consuming a set of changes to a table, right? Sort of at that row level, maybe between two transactional points in time. So for example, the change data capture for a staging table, right? Which can include other data manipulation language, things like inserts, right? And then a task, on the other hand, is basically the scheduling and running of a SQL statement, which potentially has, some stored procedures in it as well. And you can also set things like triggers for these to occur. They can be chained together as well to build your DAGs from to support those more complex processes. Okay, so to take that a step further, when you combined Snowflake Snowpark, you get some additional core functionality which allows you to enable those scheduled or event-driven executions of SQL, as well as other multi-language use cases like Python and Java and Scala and so forth. So long story short, if you're using these tools and when you combine these guys together, tasks and streams and so forth, right, it's very convenient, it's very powerful, and it's a great way for developers to continuously build out those ETL pipelines in Snowflake. Okay, now out of the box, there's even some level of observability that's provided by Snowflake, right? So things like, if you want to understand from a job perspective, right, its status, right, or the task's status, some performance monitoring kind of metrics as well, kind of from that perspective. These can all be done through different task history table functions. You combine that with Snowflake's Snowsight and kind of that usage dashboard, like I'm showing here. You can then offer up some tracking on other trending data points like credit consumption, right, and other usage across different levels of the platform. And beyond that, there is other metadata, right, that is available to you to give you some other information, right? Who owns the job? what's that job run's history, its performance, kind of tracking that performance over time. Maybe a job failed, right? Or it was killed. How long was it running? The duration of that job. These are all things that you can get. This is additional information that you can get through commands and querying of things like the account usage views and the information schema views, like I'm showing here on the screen. So all in all, powerful stuff. We highly recommend that you continue to use these today, right, to manage your ETL pipelines powered by Snowflake. So what's missing, right? Even with some of these basic observability tools out of the box from Snowflake that they provide, there are still some things that are missing. And so I'll give you a couple of examples here. First of all, folks are really, or rather for folks who are really looking to cost optimize, right? And some opportunities therein. There are some avenues that we can go down to reduce things like overallocation, or what I will refer to as how to reduce wastage. And it's not really called out front and center from a Snowflake perspective. It's really up to the end user to understand a few things, right? Like how to pick a warehouse t-shirt size. And maybe ensure that it's not being underutilized from a workload perspective. Making sure it's not too large and leaving some resources on the table for fear of underperforming, right? Or worse, a failing query, right? Because they've either timed out or didn't perform to meet the SLAs due to an undersized warehouse. So you got to find this nice balance. It's a balancing act, right? And I see a lot of customers get challenged by this because it takes a bit of expertise to find this nice little balance, and it takes time. And these pipelines, they change over time as well, right? And that can be even more challenging and even more cumbersome in order to find opportunities to cost optimize for that warehouse from that infrastructure piece. The other challenge is maximizing for performance. So are we doing things like using join operators in an efficient manner? Or are we filtering inefficiently because we're not using the right cluster keys? Are things written into the SQL itself that's inefficient? These, again, are things that are not really called out front and center with the out-of-the-box kind of tools and the dashboards that we have provided by Snowflake today. It's up to the end user to leverage all the things that they have at hand, like those various console tools that I mentioned earlier, the usage schemas and the information schemas, and even looking at and combing through and parsing logs to find errors and inefficiencies. But a lot of the time, rather, these things go unnoticed. So a lot of the time, if we're trying to solve for performance, you need to get deeper into that code. And being able to highlight and identify if there is or are inefficiencies to begin with, again, that's cumbersome, right? And it is up to the end user to find these out. And last but not least, troubleshooting pipeline failures is still very time consuming itself. Even with the observability that Snowflake provides today, I get a lot of feedback from a lot of our customers and prospects where they are spending a lot of time trying to understand, hey, which of my tasks in which job run has failed? It's almost like finding a needle in a haystack. Now, granted, the features that Snowflake provides are super powerful. It's still, again, up to the end user to harness that power to understand where to look in the first place. And I see a lot of organizations where folks are very good at this. They're good at at least some of the resources at these organizations are good at like the root cause analysis piece, right? But they're few and far between, because then on the flip side, you have some more inexperienced or junior resources that end up, tapping on the shoulder of those other SMEs, so to speak, to help them understand why things failed. So it's not as turnkey, and a lot of time is spent, on this effort kind of unnecessarily, right? And the money spent for jobs that continue to fail is still money spent, right? Unnecessarily. Okay. So now what I want to do, I'm going to switch over here. And what I want to do next is I want to show you a day in the life of using a platform like Unravel Data to help fill in those gaps, right? For solving for those things that are critical, solving for cost, solving for performance and stability. And the way that I'm going to do this is I'm going to start on this homepage. So you can see here I'm focused on this homepage to talk through a couple of things. So what are we looking at? We basically here we have a front row seat, this kind of a executive level view, if you will, of how things are going on in my Snowflake data estate, right? It's giving me a sense of the health, if you will, of my Snowflake data estate. And from this perspective, I can see a bunch of things, right? I can see some, cost usage metrics around cost, broken down into compute and storage and data transfer, right? How many warehouses am I monitoring here? How many queries am I monitoring here? How many tables? What are the size of those tables? How many users? Those kind of, typical table stake items. But from this perspective, and what Unravel provides really at its core is what we do really well. And that is we want to provide insights on how you can potentially improve on three main things. So how to improve on performance, how to reduce cost wastage, and how to increase productivity, right? How to cut back on all of those hours of troubleshooting and root cause analysis, right? Or just identifying inefficiencies in the first place. And so how do we do this? So Unravel does this by looking for those inefficiencies, right? And that can be a lot of different things. That can be, how maybe your warehouses are configured, or maybe how your queries are written, or maybe even some, table level insights, right? And so I think what I'll do now is I'll walk you through a scenario. So I'm an organization. It's at scale. I've got pipelines that are doing a multitude of things, right? It could be some, whatever, large scale analytics of years of historical kind of transactional data, right? And I need to identify trends and patterns. Or maybe I've got some other large data engineering ETL pipelines that I have to consolidate from multiple sources into a single platform like Snowflake, right? Or something more real-time, some real-time analytics of a supply chain, right? That's monitoring for some operational reporting. All of these use cases can require, different warehouse configurations, right? But maybe those data engineers have a need for a heavier compute, right? Because they have some very complex queries that they're performing. Or maybe that real-time use case, right? That operational reporting requires a warehouse cluster that scales more dynamically with the demand. Either way, a lot of different workloads require different warehouse scenarios, right? But again, it's up to the user to determine what is optimal. So what I see with customers at scale is that that's a very time-consuming task. And so they try to implement, in a lot of instances, kind of a one-size-fits-all, right? And maybe this is done through some sort of policy that was determined by trying to understand best practice, right? And this actually comes into play a lot of times where I see a lot of these best practices out there online, and then the organizations try to use it as some sort of standard. A lot of the time, this goes unnoticed in terms of what pipelines are over allocated, right? And it's very unclear to the organization in terms of, hey, what are some of those pipelines that can be optimized for cost? So that said, you'll be very happy to know that Unravel provides insight types here that specifically are meant to identify pipelines that have inefficiencies that are, affecting your cost. And so it maps to a few places here on this screen, right? So you can see here in this insight analysis kind of subsection here related to warehouses, I have 32 out of my 32 warehouses that I'm monitoring that have insights, right? And those insights go across several different kind of categories, right? Underutilization. Hey, a warehouse is underutilized when those workloads that are running on them are leaving, some resources on the table. We're leaving dollars on the table, right? We're not utilizing the full extent of those resources available or that were chosen in the first place, right? So therefore, hey, these workloads can be run on smaller and thus cheaper warehouses without performance degradation. hey, we've identified a bunch of queries running on some oversized warehouses, right? So these guys are candidates to move to, those smaller warehouses. Maybe there was some, suboptimal cluster configurations in terms of auto scaling, min and max, cluster settings. What's the impact there? What's the impact with all of these in terms of wasted cost? So how much savings can be realized from an annualized perspective in these categories by looking at and applying the Unravel recommendations? So I think what I'm going to do here is I'll dive into one of these and we'll run through one of these examples. So let's take the underutilization category here. It's very common. As a matter of fact, in my demo environment, this is where the majority of my untapped savings opportunity lies anyway. So let's look at what some of Unravel is recommending here. Right sizing warehouses. So right sizing underutilized warehouses. I have quite a few of them here. And it's basically in a prioritized list in terms of from top to bottom, highest impact in terms of that annualized savings. So let's take a look at what Unravel is recommending. All right, so what are we looking at here? This is basically a schedule, right? Which is probably pretty evident, right? Here's the days of the week across the top, and then the 24 hours a day on the vertical side here of this graph. And couple different colors. The current configuration, the warehouse size, t-shirt size, that was selected by the owner of the pipeline, the owner of those workloads, those jobs that are running here, was a 5XL. And that seems to be consistent across every day of the week and every hour of the day. Now, what Unravel is recommending is, hey, we're recommending a new configuration. You actually didn't need to select that 5XL to run your workloads and maintain your SLAs and not incur a degradation in performance or stability. You could have ran a 4XL across these times of the day and these days of the week to the tune of $70,000 in annualized savings. So if you think about this, a warehouse in Snowflake is very similar to an interactive cluster in Databricks, if you're familiar with that. It's just running. I'm submitting my queries to it. It's up to me to turn it off. So the recommendation here to downsize from a 5XL to a 4XL, right? It's pertinent because folks don't do the analysis in the first place to know if they should even start with that 5XL, right? And in terms of our recommendations in Unravel for this warehouse sizing exercise, we take in a lot of information. Idle time of that warehouse. Is it a virtual warehouse? Lots of telemetry data, right? We take all these things into consideration. The algorithm within our purpose-built AI, all we're saying is, hey, did you really need that 5XL size warehouse in the first place? No? Well, then make this small change. It's very simple. It equals less spend for you. And by the way, we're giving you an easy button, apply these recommendations. Yes, obviously from an operational standpoint, there is some back-end considerations like change control, and we work with our customers with respect to those, but it can be as simple as that. And from a warehouse downsizing recommendation, right, in Snowflake, there's a couple different ways to scale. T-shirt sizes, like we've been talking about, right? That's at your scale-up architecture. Hey, I've got my 5XL here with 16 cores and this much memory versus my, small or my medium, right, with half the cores, half the memory, or scale out, right? Auto scaling. I have one extra small warehouse right now, but later I have 10 extra smalls, right? And so when folks are considering these two types of use cases, right, when they think about scaling up first, it's because you got a lot of heavy workloads, right? You got a lot of memory and CPU requirements. You're servicing your heaviest queries. Scaling out is more of that use case around that retail use case, right? Or I guess what you could consider like the peaks during the seasonal peaks, right? During Christmas time as that example. So this example was all about warehouse right sizing based on my pipelines for cost optimization. Now let me walk you through another example here. And I'm going to now move over to this queries subsection of my homepage. So the other thing that we highlighted was being able to look for performance optimization kind of opportunities, right? And Unravel, we want to find those that would map very nicely here in this query section. And more succinctly, right, inefficient queries that were identified with opportunities to improve their performance as well as cost efficiencies, right? Queries with opportunities to improve performance and cost efficiencies. And so you can see here some of the examples. There's different categories of those insights. So things like filtering, things like join inefficiencies, SQL anti-patterns. These are all inefficiencies, right? But there's this one here in this list, performance, that I want to dig into. But before I do that, again, here's the impact of what Unravel has found related to those insights and recommendations. But here's the untapped savings if we were to address all of these 48,000 queries here in my demo environment, right? And again, there are ways to operationalize this at scale to take advantage of what Unravel is recommending in terms of these insights. So let me dig in here. I'm going to click into performance. And what this is going to do is provide me a list of all of the queries that are underperforming for various reasons. And I'm going to dig into one of these. Lots of good information here. So basically, I'm looking at this query dashboard page for that specific query. Here's my estimated cost in dollars and credits. What's the state of my query? Right now, this guy has failed. So I want to dig into why that's happened. It was actually that SQL execution was canceled. When did it start? When did it end? How long did it run for? Bytes scanned, in and out, rows affected. Who was the user? What was the warehouse size and type that was utilized for this particular query? But more importantly, from an efficiency standpoint, what were the insights that Unravel found? Those needle in the haystack, right? Unravel is being that expert in the box for you to find this for you and bring your attention to it, right? Informing you. What were those? So there are a couple things going on here. We got some slow operators, and we have a usage of functions and predicate. So let's talk about that one. Sometimes the way that we utilize those functions, right, it prevents things like indexing and pruning, and it forces us to scan a full table, right, where we otherwise would not have needed to do so had we used our function call in the proper way, right? And depending on the size of your table, that can be quite significant. So what is this telling us here? It says, hey, possibly the way that the function calls are used, this could slow down the query significantly. And we're giving you a line of code inside your query to go look at. So let's go look at line 87. All right, here's where our where clause is, right? And we're talking about a specific date. So when we're doing that, we're actually asking it to apply that to every row in the table. And when we're talking about numbers on orders of magnitude of the billions, that's very significant, right? And so as well, this slow operator, which happens to be a join, which accounted for more than 50% of the total duration of this particular step in this query, right? It affected that many billions of rows. So that example here, I just wanted to outline from that performance optimization standpoint. So again, we're solving for not only performance of that query, but also how do we cost optimize just by tweaking a few lines of code. Okay, last but not least, let's walk through what I suspect a lot of you folks are here for, right? And that's because you're actively managing your data pipeline failures, right? So that one that we just outlined was a failed query. But let's take a look at this subsection here again, and bring your attention to the bottom here, failed and timed out queries. And by the way, maybe unbeknownst to some of you, even though your query failed, right, you're still on the hook to pay for those things, right? So we want to minimize that as much as possible, right? So the more we can reduce those failures, the less unnecessary spend we're running at, right, and leaving on the table. So let me just dig into one last example here. And this one has to do with moving queries to a larger warehouse to improve their performance. So again, failed query. I'm just going to dive into the top guy here. some of the same information that we saw at the top of the other one. But in this case, the efficiency and the insight have to do with moving that query to a larger warehouse to improve its performance, right? So the timeout occurred after 1,200 seconds. The query failed due to its statement here, and so therefore it was canceled. And so the recommendation is to potentially run this query on a larger warehouse to speed it up. Obviously, there might incur a bit of a cost there, but that's part of that fine balancing act that you have to take into consideration when we're looking at these pipelines. Okay. So what we did here today is we've highlighted some of the basic capabilities from Snowflake, right? So we talked about tasks and streams, right, from an observability standpoint as well, and how customers are using that today to really create some powerful ETL pipelines powered through Snowflake. We talked about some of the gaps that the basic observability from Snowflake doesn't provide. And we looked at a short demo of Unravel's capabilities to go beyond just that observability layer and how to solve for some of those inefficiencies, right? More specifically around performance, cost, and stability. So what I'm going to do next here is, I know we've got some questions that came in during the demo. So yeah, so question number one, I'm going to pull my chat over here. Okay, so what are some common inefficiencies in Snowflake ETL pipelines that can lead to unexpected budget overruns? Right, yeah, so I guess this was one of the first questions that came in earlier, but we just covered that. So there could be some cost savings and efficiencies, right, that are based on just configuring your warehouses appropriately, right, from that scalability standpoint, right, those min, max kind of settings, that perspective. Code level inefficiencies, we just talked a little bit about functions and predicate and, the using of joins inefficiently, warehouse sizing from that t-shirt size perspective, right, and a lot more. Next question we have here is what kind of performance tuning techniques can be applied to Snowflake jobs to optimize speed and cost effectiveness? Yeah, so this could primarily be a result of code issues, right? Those code level issues. So avoiding or properly using, again, those functions, right? Ensuring those joins are doing or are properly structured in the first place. We just mentioned this, but again, setting that auto scaling min maxes and others that could be impacting performance, all of which, as I showed you, Unravel has specific recommendations just for that. And so here's another question. Actually, looks like the last one, but this is a good question. So can you share a real world example of how organizations have successfully reduced costs by optimizing their Snowflake ETL pipelines? So yeah, a recent example, actually. So a healthcare company who was struggling to maintain costs, right? Kind of a usual use case. This company basically outran their budget in 4 months, right? Their annual budget cycle within the first 4 months. And they anticipated a lot more growth. So what they needed was the ability to solve for cost, but not impact performance, right? This way, they would be able to get their costs to be more predictable, and they could onboard, all of these future workloads that they knew were coming down the pipeline. But they couldn't do this, right, because they had this artificial barrier due to this out of control cost. So in their environment, we entered into a POV, and in their environment, they were using Snowflake tasks, right, to automate some of their SQL-based workflows in order to enable them in that scheduled manner, right? But what they were also doing is using a set of predefined warehouses with like those standard sizes. And they combined that with role-based access control, right? RBAC based warehouse assignments that were related to the typical workload of the users in that role and what they would be running. So basically someone decided on a set of warehouses or a size of a warehouse that they should be using, right? And when we pressed them and asked them about this, say, hi, how'd you guys actually select and structure these policies? They simply said, this was the recommendation that was recommended from some solution architects. So what they were doing basically is they did their best, right? But it ended up being a quasi one size fits all across, these pre-assumed use case types, right? It was not specifically tuned. And so when during the POV, Unravel observed how these pipelines were performing, a lot of the recommendations came back for more specific warehouse sizing based on these pipelines, some of which those pipelines were very complex. The end result was to provide more flexibility and selection based on some of those additional warehouse t-shirt sizes. And so what did this net out? Basically, within the first few months, this is after they became a customer, this basically netted out to the tune of a few $1 million in terms of savings for these folks. And actually, we'd love to do the same thing for you. And to that end, if basically what you think I've been sharing with you today can help you, then I would encourage you to go today and get a free Snowflake health check, right? Simply by visiting this URL on the screen here, right? So unraveldata.com/snowflake-health-check-request. Yeah, go ahead and do that. Check that out. It's free to you, absolutely no cost to you to do this. So I would definitely recommend you to try out the product, see what life could be like if you're using Unravel for your data ops and your FinOps observability use cases. Again, my name is Hal Schreiber. Thank you. We'll see you soon on the next one. Bye-bye.